Hello everyone. This video is about the simulation of single-phase semiconverter. Single-phase semiconverter is a single quadrant converter and which consists of 4 devices, 2 thyristors and 2 diodes. Let us draw the circuit. Let us create a blank model. In order to draw the circuit, we need AC voltage source, double click on the AC voltage source. Let us have the amplitude as such and let us change the frequency to 50 Hertz and then click OK. Then we need thyristor. Click on the thyristor and press Ctrl R to rotate it. We need 2 thyristors. So click on the device, right click on the device and drag. Let us rename the device T1 and T2. Then we need 2 diodes. Let us rename the diodes as D1 and D2. Then in order to give the gate pulse to the thyristors, we need pulse generator. Click on the pulse generator. Let us have the magnitude as 5 and time period is nothing but 1 divided by 50 Hertz. Then in order to give the phase delay, we will consider the firing angle to be 30. So 30 divided by 360 into the period, which is 0.02. Now let us take one more pulse generator by right clicking on the first pulse generator and dragging it. Then we can have the firing angle. The firing angle of the next thyristor will be 180 plus 30, so which will be 210. Then we will connect the pulse generators to the gate terminals of the 2 thyristors. We will connect all the devices to form a bridge-like structure. Then we will connect the source to the bridge. 。 . 。  . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Then we will connect the load. Choose RLC series branch. And let us take the load to be initially R. And let us have the resistance value as 10. And click on this, click on this and press Ctrl R. Then connect this load to the bridge circuit. We need to measure the voltage and current of the load. So to measure the voltage, we need voltage measurement block. And to measure the current, we need current measurement block. The voltage measurement block is connected in parallel with the load. And the current measurement block is connected in series with the load. In order to see the waveforms, we need scope. Double click on the scope. And click on configuration parameters. We'll change, click on the main tab and change the number of inputs to be 2. Then in order to see the two waveforms in the separate windows, we will choose layout in the view tab and then choose two boxes. So we will connect the voltage measurement and the current measurement blocks to the sinks. In order to run the simulation, we have to include power GUI block. We have to include the power GUI block. Then only the simulation will run. Now let us take the stop time as 0.1 because the time period is 0.02. If we choose 0.1, we will be able to see 5 complete cycles. We can run it for 5 complete cycles and we'll be able to see the outputs for 5 complete cycles. Now let us run this one. Now the model is running. Once 100% completed, we can see the waveform in the scope. So the first waveform indicates the current waveform and the second waveform indicates the output voltage waveform, load voltage. This is load current, first waveform, and the second waveform is load voltage. This is the output of the single phase semiconverter for resistive load. Let us change the load to RL and see what happens. So even for RL, there is no much variation in the waveform because this is the output voltage waveform will always be positive waveform because the circuit used is the semiconverter, which is single quadrant converter. So output waveform will always be positive. So this is a single quadrant. So output current and voltage will be always positive. But if we increase the inductor value, then this discontinuity can be avoided. So let us increase the inductance value to 10 millihenry and see what happens to the current waveform. There will not be any change in the voltage waveform, but the current waveform will experience a change. So we can find here that the current waveform is continuous conduction waveform, continuous current waveform. If we increase the inductance value, we will be able to get the continuous current conduction more. But always the output voltage waveform is of this shape because of the semiconverter nature. This is a single quarter converter. So that's all about the simulation of single phase semiconverter. Thanks to everyone for watching this video. Thank you.